Continuing to use the FSAE steering wheel simulation file, let's take a look at constraining the motion of the design for simulation. To this point, we've changed the materials on the components for the study and applied a moment load. Now we'll limit the flexibility by applying constraints. We will use the constraints to create a worst-case scenario where the shaft is completely immobilized so we can see the effect it would have on the splines if we continue to try to turn the wheel. Let's expand the constraint dropdown on the toolbar and select Structural Constraints. There are options for constraint types, but we will choose Fixed. Even the fixed constraint has options for flexibility along an axis, but we won't use those at this time. I'll select the cylindrical face of the shaft, then orbit around to select the bottom. This would still allow the faces immediately below the steering wheel to turn, so we'll select the bolt holes and the bottom as well. Then we can click OK to finish placing the constraints. The constraint case we've built wouldn't be ideal for some studies, but this will help us focus on the splines. Zooming in, we can see the icons that help to remind us that the faces were fixed. There is another option available for this type of model called a bolted connector, but we won't use it for this study, but it's a great way to simulate having bolt stacks in the design with much better performance than simulating with models of bolted connections. So once again, let's save our work and take the next step.